So as we've seen from the previous example, we can work out the distance between any 2 points if we draw a picture and draw a graphical representation on a set of axes. That's good and effective when we get there in the end, but it is rather time consuming. So what I'm about to show you is a slightly quicker way to do it. We can do it algebraically. If we develop a general form or an equation that can do it, we can just push numbers into the equation and now pop the answer, meaning we don't have to draw a picture anymore. So here I've drawn up, similar to what we had before, got a point here, I've labelled it A, it has coordinates x1 and y1. Over here I've drawn another point here called and labelled it B, it has coordinates x2 and y2. So it's going to have a y value, some y value up here, so we'll have an x value here. As you can see, I've also drawn the remainder of the right angle triangle. So if I wanted to, I could label this the y step. What that means, it's the y value, the increase in y to get between these 2 coordinates. Similarly, I can label this the x step. This is the value that the amount that x has to increase by to get from A to B. So you can see I've broken it up into 2 components. So if I were to write an algebraic expression for the x step, I have x step equals x2 minus x1, and similarly for the y step, as x1, I have y2 minus y1. So going back to our earlier example, if I wanted to determine this distance here, I'd say that d squared in this instance equals the x step squared plus the y step all squared. And if I substitute these values in for the x step, I'll have x2 minus x1 all squared plus, and then I substitute the y step in, I'll end up with y2 minus y1 all squared. Now, I can then say that d equals the positive square root of that, minus x1 all squared plus y2 minus y1 all squared. And there we have an algebraic expression that we can just push and insert our values straight into. So if, for example, we go, alright, well, let's actually use this picture and say, well, hang on, x2 looks like it has the value of 4, y2 in this case looks like it has the value of 5, x1 here has the value of 1, and y1 has the value of y1. So here I could say that d equals the positive square root of our x2 value, which is 4, and our x1 value here, which is 1, so 4 minus 1 all squared plus y2 value, which is 5, and our y1 value, which is over here, which is 1, all squared, taking the square root of that, which is the positive square root of 3 squared plus 4 squared, was the positive square root of 9 plus 16, was the positive square root of 25, equals plus 5. There we go. So hopefully from this example we can see that we now generated an algebraic way of solving this problem rather than having to draw a picture every time.